Today we are going to start talking about scientific notation. This is the last section for this chapter. We're going to spend today and Monday going over scientific notation. Then on Tuesday we'll review the entire chapter, and Wednesday you will have a test. So plan on next Wednesday having a chapter test on chapter 8. Alright, by the end of this lesson today, you're going to be able to identify numbers in scientific notation, convert a number from decimal notation to scientific notation, convert from scientific notation to decimal notation, and fix numbers so that they are truly in scientific notation. So let's start by talking about what scientific notation is. It is a number that is written in scientific notation if it is in the form c times 10 raised to the power of n. And n is a number, an integer. C has to be a number between 1 and 10. Now it can equal 1, but it has to be less than 10. Alright, so let's go ahead and look at what that means. So the distance of Manhattan Island is 13.4 miles. Well, again, we don't want a number that is bigger than 10. So we can move this decimal over to the left one space so that this is now 1.34. But because we moved the decimal, we need to say times 10 to the power of 1 because we moved it one place. And then that's in scientific notation. Now with this example, again, I want a number between 1 and 10, and it cannot equal 10, it has to be less than 10. So if we know that we have with our whole number, our decimals at the right, I'm going to take it and I'm going to move it 1, 2, 3, 4, 5, 6, 7, and I'm going to stop between the 9 and the 2 so that I have 9.29 as my number, times 10. Now how many times did we move it? Well, let's see, 1, 2, 3, 4, 5, 6, 7. So this would be 9.29 times 10 to the 7th power. And that is all there is to writing a number in scientific notation. So let's go ahead and keep practicing. In these next three examples, we want to tell whether or not it is in scientific notation and explain why or why not. Our first number, 213, this is not in scientific notation, first of all, because the number is greater than 10. If we look at this next example, this is an example of scientific notation. We have a number that is between 1 and 10 times 10 to a power that is an integer. So yes, the second one or the middle one is in scientific notation. Our last example, it looks like it could be in scientific notation. However, our number that we start with, this 54.32, again, this number has to be between 1 and 10, and that is clearly not. It's 54. So the only one here that is in scientific notation is the one in the middle. Alright, let's go scroll down just a little bit. Alright, let's take a look at what happens when we multiply by 10 to a power. What does 10 cubed equal? Well, hopefully, oh, phone's ringing. Time out. Alright, so let's get started again. We're going to look at big numbers versus small numbers, and we have our problem 2.83 times 10 cubed. And we want to know, is the number going to be getting bigger or smaller if it has a 10 cubed versus if it has a 10 to the negative 3? So think about it, 10 cubed is saying 10 times 10 times 10. That's a rather large number. So if we multiply 2.83 times 10 cubed, we're really getting 2,830. That's a number that's getting larger. It went from 2.83 and went to a 2,000. All right, now over here we have 6.12 times 10 to the negative third. Here we move our decimal to the left and our number is going to get smaller. So if we move our decimal to the left 3 spaces, and let me write this out so you can see what I'm doing. I'm taking this decimal and I'm moving it left 3 spaces. So we have 1 space, 2 space, 3 space, and I'm stopping here. Now for each of these, I guess you kind of call like spaces, we need to put in a 0. So this number actually turns into 0 or 0.00612. So here we've gotten a lot smaller. We've gone from a number that's 6 to a number that's less than 1. Right, so basically what we're trying to say here is that if you have an exponent that's negative, your number is going to be smaller, and if it's not, then you've made a mistake. And if you have a positive exponent on your 10, your number should be getting larger. All right, let's go to the next page. Let's practice writing some of these in decimal notation. This is clearly scientific notation. If it's 3.128 times 10 to the power of 3, we're going to take our decimal, move it 3 places to the right. It ends right here. So this number in decimal form would be 3,128. Over here we have 7.92 times 10 to the second. So we're going to take the decimal and move it twice to the right, and we get 792. Now C and F, we don't have any problems. So let's go to D. Here we have to the -5. When we have a negative exponent, we're going to move left. We're going to move left 5 spaces. So we have 1, 2, 3, 4, 5. So if I fill in all the spaces with 0, we get 0.000192 as our answer. And for the last one, we have to move to the left 2 times. So 1, 2. Put in a 0, so our answer here is 0.0145. Alright, let's go ahead and move down. Here we want to move from from decimal notation into scientific notation. So I know that for this number to be between 1 and 10, the decimal has to go between the 6 and the 0. So I'm going to rewrite this as 6.02. And for my decimal to get to that spot, I had to move it 1, 2, 3, 4, 5, 6, 7, 8 spaces. So this would be times 10 to the 8th power. And that's it. Over here, again, for this to be between 1 and 10, I would put it between the 1 and the 0. So we have 1.0 times 10, and we had to move it 1, 2, 3 spaces. Here we would say this is 1.0 times 10, and we had to move it 1 space, so times 10 to the first. Alright, now here we were going to have some negative exponents, because again, here we have a smaller number. So I know that the decimal needs to go between the 2 and the 5. So we have 2.54 times 10, and I needed to move it 1, 2, 3, 4, 5, 6, 7 spaces. So it's 2.54 times 10 to the -7. Over here, I know that the decimal would go between the 1 and the 2. So it would be 1.24 times 10. Now I need to count how many times I moved it, which was once. So to the -1st. Right, over here, I need to move it after the 1. So it would be 1.0 times 10, and I had to move it 2 times. Alright, so there you go. That's writing numbers from decimal form to scientific notation, and just a little bit we did a few problems ago we did from scientific to decimal form. Alright, so here we've got some real life numbers that are rather large, and we're going to take these numbers and write them in scientific notation. So what I'd like for you to do is go ahead and hit pause and try and write these numbers in scientific notation on your own. Once you are finished, hit play and see if you got the answers correct. Alright, so hit pause, try these on your own, and when you finish, hit play. Alright, hopefully you have gotten most of these correct. Take a second to look at your answers and check them with the answers on the screen. If you didn't get one correct, take a second and look at and see if you can find what your mistake is. But let's go ahead and move on. Alright, here we're going to practice writing a number in decimal form and scientific notation. So over here our number is 12.3 times 10 cubed. So if I want to write that in decimal form, I know I'm going to move the decimal 3 to the right. So 3 to the right would be 1, 2, 3, which means I have to put in 2 placeholders. So decimal form, it would be 12300 or 12,300. In scientific notation, this would be 1.23 times 10. Now, if my point was here, it would be 1, 2, 3 times 10 to the power of 4. All right, 145.32 times 10 to the 5th. So I'm taking my decimal and I'm moving 5 to the right. 1, 2, 3, 4, 5. So I have 3 zeros as a placeholder. So I'm going to write that number. 1, 4, 5, 3, 2, and 3 zeros. So this comes out to be 14,532,000. And to write this in scientific notation, it would be 1.45 times 10. Now if my decimal was here, I would have to move it 1, 2, 3, 4, 5, 6, 7 times to make it the real number. Alright, letter C. So to write this in scientific notation, I'm going to take this and move it 2 to the right, which means I have to put on a 0. So we've got 2,000, or I don't know if it's 2,000, but 23673. 23673, So this is 236,730. To write this in scientific notation, it would be 2.36 times 10, and if it was here, we'd have to move it 1, 2, 3, 4, 5 times, so times 10 to the 5th. Alright, letter D. Now, if I moved it 5 to the right, we get 1, 2, 3, 4, 5, which is 2, 3, 5, 6. So our real number is 2,356. To write this in scientific notation, it would be 2.356 times 10 to the 1, 2, 3rd. Alright, here, if we move this 7 to the right, we'd have 1, 2, 3, 4, 5, 6, 7, which means 2 zeros as placeholders. So we'd have 3, 6, 7, 0, 0, which would be 36,700. In scientific notation, it would be 3.67 times 10. Now, if our decimal was here, it would be 1, 2, 3, 4. Alright, so last two were blank, so let's go ahead and just keep going. Now here we're dealing with some negatives. So first let's write this in decimal form. So remember, if it's negative, we move left. So we're moving left 3. 1, 2, 3. So we need 3, just 2 zeros as placeholders. So 0, 0, and then 0, 1, 2, 3. Now if I wanted to write this in scientific notation, it would be 1.23 times 10. Now I moved this 1, 2, 3, 4 to the left, so it's a negative 4. Alright, here I'm going to move it 5 to the left, so 1, 2, 3, 4, 5, which means we have 4 zeros. So 1, 2, 3, 4, then 0, 3, 2. So this is our number as a decimal. In scientific notation, it would be 3.2 times 10. Let's see, 1, 2, 3, 4, 5 to the negative 6th. Here we're taking our decimal and we're moving it left 2. 1, 2. So we're putting in an extra 0. So how many zeros do we have? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, and a 3. And in decimal form, it would be 3.0 times 10. Let's see if our decimal's here. 1, 2, 3, 4, 5, 6, 7 to the negative 7. All right, 235.6 times 10 to the negative third. We're going to take our decimal, move 3 to the left. 1, 2, 3. So we get 0.2356. In scientific notation, that would be 2.356 times 10. Now to get this, we moved it, let's see, we moved it there. So this would actually be, well, this is a tricky one. So we're going to take this and move it to the right 1. So this would be times 10 to the first. Alright, the next one, so we're moving left 7. 1, 2, 3, 4, 5, 6, 7. So we get 0.0000367. This would be 3.67 times 10. Let's see. 1, 2, 3, 4, 5 to the negative 5th. Alright, that's it. Let's go, let's see if there's another page. And there's not. So that is all there is for the notes for today. Go ahead and ask for your homework and get started.